Imagine someone you love is diagnosed with an incurable disease. Think of the hopelessness and urgency you would feel wishing for that miracle cure. Now imagine a machine that can test countless treatments in the blink of an eye, finding that cure in weeks instead of years. What once was incurable might just suddenly become treatable. This is not science fiction or even a gizmo from Tony Stark's garage. No, this is the potential of quantum artificial intelligence, or QAI, and it's becoming very real. I'll pull back the curtain on QAI, what it is, where it's already present in our lives, and why you, yes, you can help write the next chapter. First, let us ground ourselves. What is quantum artificial intelligence? Quantum AI merges two of the most groundbreaking technologies of our time: artificial intelligence and quantum computing. Artificial intelligence is fantastic at spotting patterns and learning from data, while quantum computing harnesses the strange properties of physics to compute in ways classical computers simply cannot. Together, both of these combine to form quantum artificial intelligence. Instead of crunching through one scenario at a time, a quantum computer examines many possibilities simultaneously, like exploring every path through a maze, all at once. And AI guides this exploration, asking the right questions and interpreting the answers. In simple terms, QAI is like giving our smartest algorithms a rocket engine. Problems that stump our fastest supercomputers today could become solvable. And this is not just theory. Around the world, scientists are already taking the first steps into the QAI era. The implications span many fields: healthcare and medicine, logistics and supply chains, finance, and even climate modeling. Let's start off with healthcare, because it's personal for so many of us. Now, how solvable does the unsolvable become? Imagine someone with a neurodegenerative disease so rare it only has 50 documented cases. Classical drug discovery is like fishing with a single line in an ocean of 10 to the 60 possible molecules. You haul each one up, test it, and repeat. It's noble, no doubt, but it's also agonizingly slow. Now imagine QAI casting a dragnet the size of the ocean itself. Last year, the Cleveland Clinic unveiled the first quantum computer dedicated solely to healthcare. In early simulations, quantum-enhanced models predicted protein folding configurations for the Zika virus exponentially faster than classical supercomputers. Elsewhere, QAI is ranking entire chemical libraries, billions of compounds, in silico before a chemist even picks up a pipette. Now, this may make you ask, does this make human researchers obsolete? Far from it. It empowers researchers to ask deeper questions, like, why did candidate number 7,000 bind better than number 7,001? That's the beauty of QAI. It handles the brute force search so the humans can focus on insight. And while heroic medicine may capture headlines, let's pivot to a frustration we all know: packages that mysteriously vanish into the ether, and grocery shelves that become magically empty. These supply chains are living ecosystems. There are thousands of ports, trucks, tariffs, warehouses, and weather systems entangled in real time. Remember the container ship Ever Given lodged sideways in the Suez Canal in March of 2021? 6 days of blockage cost an estimated $9 billion per day in lost trade. That single error revealed how brittle our global pipeline is. But why is it so fragile? Well, part of the reason is because classical optimization tools slice that complexity into bite-sized subproblems, thereby sacrificing that holistic accuracy. QAI, it manages to keep that complexity intact. Here's the best way to explain it. Imagine that I'm an optimization function, and my job on the graph is to find the highest maximum. If I'm a classical computer, I may find the arrow on the left, or more likely the arrow on the right, to lead to the highest maximum. This is what a classical computer would think. A quantum computer sees this. It's able to see the true absolute maximum because it's able to utilize its unique property of quantum superposition to exist on every point along this graph at the same time. This allows quantum AIs to find the true absolute maximum and thus be better at optimization algorithms. Pilot studies by logistic giants have shown quantum routing algorithms reducing last mile delivery times by 18 to 22% while trimming fuel usage. More than margin gains, that speed can be life-saving during natural disasters. Imagine QAI rerouting medical supplies through a labyrinth of washed-out roads before the storm has even fully formed. Currently, Pier 300, the second most popular pier in the Los Angeles shipyard, uses a quantum AI algorithm to optimize all the moving parts. In fact, it is stated that cranes have increased their number of deliveries by 60%, and trucks spend 10 less minutes waiting for payloads. And what's important to realize is that while 10 minutes may not sound like a lot, it's a lot more than you may think. Because those 10 minutes, they're compounded on a global scale, which could result in millions of dollars saved. In short, QAI can turn things like traffic jams and empty shelves into relics, silently conducting the orchestra that is global commerce. The next stop, money. Modern markets are essentially chaotically coupled, non-linear systems. Think the butterfly effect, but with dollars. Portfolio managers run Monte Carlo simulations day and night to gauge risk, with each run being one hypothetical future. A quantum computer can entangle those features, sampling thousands of Monte Carlo simulations simultaneously. JP Morgan Chase, Goldman Sachs, and the Banco de España have each reported prototypes where quantum algorithms have outperformed classical benchmarks in portfolio optimization or fraud detection. And what's at stake isn't just trader bonuses. It's your retirement fund, the mortgage rate on your first home, the scholarship endowment of your local university. They all rely on financial risk models. And if QAI can spot tail risk events earlier, a 2008 style collapse might be softened or even sidestepped completely. Now, climate is the mother of all coupled systems. Oceans, clouds, forests, ice sheets, human industry are all swirling in feedback loops. High-resolution climate models chew through petabytes of data and still can't capture every eddy of wind. That uncertainty costs lives when wildfire seasons arrive earlier than predicted or hurricanes intensify overnight. Enter quantum accelerated partial differential solvers. In 2024, a European research consortium was given access to a 127-qubit processor to simulate aerosol cloud interactions, an elusive force factor in determining rain. That leap in temporal resolution could give coastal cities weeks of additional prep time, and thereby be saving lives. But remember, technology alone never transforms an industry. People do. QAI's promise will stall without human translators who are able to speak both quantum and classical. So if you're a technologist, download the open source QAI SDK tonight. Run the tutorial, break something, and learn from it. If you're an educator, bring quantum thinking exercises to your classrooms and let students play with virtual qubits the way that they play with Lego. And yes, ethics. Because quantum speed also means quantum scale mistakes if bias creeps in. Diverse teams aren't just nice to have, they are fail-safes. In other words, how many individuals that you know can explain right now what a quantum bit is? That lack of a number isn't just daunting for the future. It's an invitation to learn and be ready for the next phase. Remember, QAI is not a destiny written by a handful of PhDs. It's a collaborative novel. And Act 1, it's still on the whiteboard. And if you want an example, look at me. I'm not a PhD graduate, as you can clearly tell. I just turned 17 3 weeks ago. But I'm passionate about practical applications of quantum artificial intelligence, leading me to be on this stage, giving my passion a purpose. This is how QAI will evolve. Now, let's quickly discuss what QAI will not do. Quantum computers will not break all encryption tomorrow. Today's noisy machines can't yet crack modern keys at scale. And remember that post-quantum cryptography is also advancing in parallel. Additionally, quantum AI will not replace all human jobs. History shows that automation shifts tasks, yes, but paradoxically expands demand for the uniquely human: empathy, creativity, and judgment. Lastly, quantum means cold, expensive labs forever. While this is true for now, as current quantum computers, like the ones that you see on the screen, have to be chilled to millikelvin temperatures, hardware roadmaps predict room temperature quantum chips within a decade. Quantum artificial intelligence is not about exotic physics. It's about amplifying human ingenuity until incurable, impossible, and too late become historical footnotes. For decades, the phrase quantum leap was a metaphor for an almost magical jump. Now, it's a machine. And while it won't fold your laundry or remember your friend's Wi-Fi password, it just might help us solve those problems that used to end with shrugs and condolences. We are standing, all of us together, at the edge of that leap. The takeaway is simple. Stay skeptical, stay curious, but don't stay on the sidelines. Let's make this quantum leap count. Let's solve the unsolvable together. Thank you.